It is fair to say that in the previous example, we've overcomplicated things a little bit by having a generic type here, because what we could have done instead is we could have written it differently in a much simpler way. We could have said here is a function called print it2, which doesn't have a type parameter, but instead what it does is it takes z, which happens to be a reference to something printable, like so. However, the behavior that this would result in is completely different to the behavior that we've had here. So let me get rid of this, and I'll get rid of the to part, and we'll implement this function. And the implementation is exactly the same. It's still the same print line call with the printable being called with format. However, the internal operation of this particular process is slightly different, because let's talk about what's actually happening here. So whenever this function gets called, it may be called with a printable. Now, what is a printable exactly? Well, you can think of a printable as a pointer to A or B, but the type information about this thing being a string or an int is actually stripped. It's what's called type erasure. So essentially, when you pass the argument, and the arguments now have to be references, when you pass the argument, all information about the fact that A is an int or that B is a string is actually lost. All we have is a so-called trait object, and that's essentially a pointer which just tells you that yes, this thing is in fact a printable object. So we can feed both of these pointers or references effectively into the printed function, and inside the function something strange happens, because remember in the previous example when we called the format, we knew that in both of these instances we were actually calling a very specific implementation, because the function itself yielded two implementations. One of those was calling this particular method, and the other was calling this particular method. Now here, what's happening is something called dynamic dispatch. So essentially what happens with this function is this function has to look at the type of argument of z, and it has to make a decision on which method called format to actually call, depending on the type that this is. So if it looks at z and it sees that z happens to be an int, it's going to call this particular method, and if it looks and sees that it's a string, it's going to call this particular method. So once again, I mean, if we run this, the end result is absolutely the same, but now we're putting more pressure, we're making the system work harder, because essentially the compiler can no longer infer in advance which function to call. So this is something that happens at runtime, and as a result, it's a more expensive call.